So Module 4, we're going to be looking at the relationship between soils and climate change. And the little outline that I have for us today includes 3 parts. One that we're going to look at the soil and climate connections. After that, we'll look more deeply into, there's that word again, you have to use the word deeply because we're here today. The soil and the carbon cycle, and then I'll walk you through a lesson set on how you can integrate this topic into your classrooms. Okay, so task time. So we're going to do this. We're going to do this very open-ended because I'm just kind of keeping an eye on the clock as well. What connections are there between soil and climate? Soil and climate. And I think earlier in the day you heard about CLORP. There's CLORP stuff, whatever, C-L-O-R-P-T, yeah. Yeah, so climate was one of those. What I want you to do is think about that C and that CLORP. And so what comes to mind when we think about climate and soils?
Erosion.
Okay. What is the connection between climate and erosion?
Like if you're, like we were just talking about the clumping and things like that, if it's not clumped enough that, and you don't have like the good structure, that you could have more erosion, which could affect the climate, maybe.
All right, let's leave it up here. We'll be thinking about mechanisms as we make our way through. This is great.
What about like carbon sinks inside the soil, like, natural gas, oil, and how they're being burned and put in the atmosphere?
Okay, and so so how are you suggesting that the soil is a sink?
I'm obviously thinking like deep in the soil, but still part of.
Oh, so you're thinking about it being a reservoir?
Yes.
Ah,
yes.
Okay, terrific. Thank you. Others?
Mining puts a lot of different chemicals into the land that can then go into water systems and end up into the water cycle.
Okay, so mining and the disruption of the soils? So, we're thinking about climate. Think about the climate, or how climate might, how the soils might be different, maybe in the tropics versus right here in Chicago.
I was about to say temperature.
Okay. And so, what would temperature? I'll give you a hint that Jen's little piece in the previous module kind of alluded to this a little bit. How would temperature influence soils?
Different minerals that are in the soil, because they were saying that like in like the south, you might have like the red soil because it's warmer in the south than it is up north. So, and they said that the color came from the different minerals that were in the soil.
So looking at soil type, so the temperature might influence soil type, and that goes back into Rhianna's piece on soil chemistry, and Meninder's piece as well. Other connections?
Speeding up biological processes and decomposition of soil organic matter.
Okay.
Or slowing down.
Speeding or slowing
Yeah.
Right, regardless of what, depending on where you're at.
It's that word that we want to use with students is what, rate? Get students used to using the word rate. Okay, rate of decomposition.
Yeah.
And so that would bring together both speeding up and slowing down. Yeah, great, thank you.
Water, like
Water
places with high
retention.
water content, the soils tend to get leached a little faster. Or I should say high precipitation.
Yeah. Okay. All right, others? How does climate influence soil formation? So we know that it has a little bit to do with the breakdown of different minerals or the chemistry of the soil to create different layers in the horizons that we find. We know that microbial life is affected by temperature. And let's see, what else? Okay, and I think we can actually go back to what you had said as well, that there might be a relationship between the high precip, okay?
And low precipitation for those areas that don't get as
Okay.
much moisture.
Precip, okay. And so low precipitation would lead to
Drying out of soil.
Thank you. This is a terrific start. Now, I didn't put in here climate change because I wanted us to think more holistically about climate, that we have these natural interactions between our climate system and soils. But now we think about a little bit more deeply about climate change and how climate change might influence these. And so let's take a look at our list. And are there some things here? There's one in here that actually is a real nice fit. Take a look at this list and think about climate change now. How is climate change going to influence any one of these activities between these relationships between climate and climate change?
Temperature for sure, yeah. But it's, you know, the global temperature is rising at a faster rate,
Okay.
which could change, like make things like decompose faster,
Okay.
maybe.
I'm sorry to
Make things decompose faster.
Okay. Speeds up rate of change.
Is climate changing affecting the soil as far as for growth for agriculture?
Okay. And thoughts on that?
If you're growing something in a certain climate and your climate is in your certain area of the world and your climate is changing, you may no longer be able to grow that if the soil is being leached or different things are happening in that particular area.
Okay. And so, so agricultural production, is that a word to encapsulate it? Okay. Production. Changes, absolutely, absolutely. We do have changes, whether it's heating up or cooling down, depending upon where you are globally. We know that precipitation has become more variable, and so that's going to have an impact as well. Others, look through this list, can you think about climate change? Yeah.
Changes in precipitation, in particular, are going to change the plant life, which is eventually going to affect the life in soils.
Okay, great. And so, so you're going back to our last module with Jen with the microbial life? Okay. We like to use the word impacts quite a bit with climate change, so impacts on microbial life. Okay, you're on a roll. This is great. Thank you.
Maybe like wildfires, you know, put more ash into the soil.
Yeah, so there is, reading a while back about this, about the impact of, you end up burning the top layer of the soil and that creates a skin of some sort.
The surface of the soil it can become hydrophobic,
Okay.
so the water will no longer infiltrate into the soil and it just runs right off. And that's what causes, like, you see a flash flood after a wildfire in California. That's why.
Thank you for bringing that up. So wildfires impacting soils.
I don't know how this reflects, but I was just thinking about like the news and what she brought to mind, like all the mudslides and different things you're seeing. I'm sure that's
So
reflecting that too.
So we have high precipitation that's actually going to have an impact on erosion. That's up here. Yeah. Others?
permafrost in the Arctic that's thawing.
And that's what we're seeing here, is that there's quite a few relationships, that it's not just the soils, but there are quite a few that are living together. Okay, so we did that. We looked at soil and climate change, and so just some big bubbles here. So we can look at climate and climate change and its linkages to soil formation, where you have where it's warmer and wetter, you're going to have deeper soils. Where it's more arid, you're going to have thinner soils. Where it's cold, you're going to have thinner soils. So the whole moisture temperature thing is going to have an impact on the depth of soil formation and the type of soils that you have. The soil type, you have a poster, I think, that was given to you, that it gives you the 12 soil orders. Take a look at that. Those soil profiles are amazing. And take a look at geographically where each one of those come from. If you are somebody that gets the Earth Science Week toolkit, Earth Science Week comes up every year in the mid-October, what you'll see is the poster that's in there is actually one that's on soils of the world. So take a look at that and share that with your students if you do get the toolkit. But I've actually put together a small activity. I've gotten a number of those posters, but it's also available online as a PDF, and have my students do a compare and contrast of those soil orders. How are they the same? How are they different? Some of those orders you're going to see those clear horizons, others you're not, and beckons the question why. The soil colors are just so different. Why do we have all those differences in soil color? And are they geographically centered in a certain spot with those colors? So there is a direct link between climate and soil formation and soil type. And then the carbon, we have carbon storage in a couple different places. We have carbon storage down deep below the soil and into the bedrock, but we also have carbon that's sequestered in with the microbial life and actually the macrofauna that we see on the surface and in the root systems. So very important here. But then we can look at climate change, and climate change on the bigger scale can lead to drought, it can lead to flood, and it can lead to erosion. And then we can go into details, big details on each one of them. What I'd like to do, though, is focus us now on the carbon piece of this, and because that's, if we're looking at climate change, we're very concerned about that excess carbon. And I'm going to give you a starter, and then you're going to kind of go from there. And so what are some places where we find carbon, bigger places where we find carbon?
The ocean.
The ocean. Ocean's one.
From us.
Us. Two. Humans, yeah.
Atmosphere.
Atmosphere, good, good.
Plants.
Plants, yeah. And let's see, where are they? Oh, and then Jen's last piece was on microorganisms in the soil. Okay, so those are the big five. What I'd like you to do is I'm going to give you some arrows for a couple teams, and the other teams are going to have to, you're going to make some arrows. You can use these smaller Post-its and show the connections amongst those. That'll get you just started and having a conversation. And I'm curious as to how you're going to connect these.
I mean, I feel like we're going to have arrows to a lot of, I don't know if you have just a...
Oh, like maybe put in the center?
You're going to have them... Everywhere? Everywhere, yeah.
Yeah.
Soil organisms take in also.
They also emit to the atmosphere, right?
Yeah, like everything connects to the atmosphere really easily.
Yeah. Some double arrows or double arrows?
Let me start making some double arrows.
How's that?
And then we could also do
this one can also be this could also be back and forth.
Everything's connected to everything.
Connected to everything.
Now, where else do we find carbon? One on each.
Touch you know?
There you go.
Yeah.
We made a connection.
They have a lot of the similarities, and I suspect that your students will come up with those. But what I would suggest doing is prodding them a little bit more to be thinking outside the box. And if with this activity, you could actually have them go into, take the plants and break it down into grasses, break it down into trees, and have them really expand and encourage them. But that's great that we're putting all this stuff down on a desk, but it's the mechanisms that we need to identify too. In other words, how is it that the carbon gets from one place to another? And so that's where you need to kind of orchestrate a little bit and we really didn't have the time for me to do this and prod you, how does it get from one place to another? And talk about those mechanisms, which are so important to the carbon cycle. But then once we talk about the mechanisms, then we take it to the next step and talk about the disruptions with those mechanisms. We talk about the changes. When we're looking at climate change, I want you to take a look at your models now and think about a small fraction of this. What you've just created is a very complex system of the carbon cycle. And to really understand it, what we need to do is start isolating small pieces of it and study it. And so we want to study those plant-atmosphere exchanges. We want to study those microbial, soil microbial and atmospheric changes. How does the calcium get, or excuse me, the carbon get into the ocean? And all of those things, we could start isolating. But we can also look at climate change, how it influences. So if you look at your model and there on your table, I want you to think about a small section of it and ask yourselves and ask your students, how will climate change impact them? So those arrows might turn into vectors where they've gotten a stronger arrow or a weaker arrow because that connection's no longer being made. It's happening faster. We talk about rate of change, and that's something that's going to be happening faster, or it might be slowing down or ceasing. So those are the types of questions that you can ask your students when thinking about the carbon cycle and thinking about this as a model. So remember that a model has explanatory and predictive power in science. And so explanatory, you're showing those relationships. That was our initial role here. But it's predictive. In other words, now you can look at that and start isolating and thinking about change in each one of those places and get the kids to start thinking about that. Now, how are we going to investigate it, each one of those? Let's take a look at a couple of activities that I have for you. So I'm going to walk through just a couple really quick connections because I'm looking at the time that our day is going to end before I can get through a slow discourse with all these slides, so we're going to go a little bit quicker. So this is just an image that's showing you when we're thinking about the carbon cycle related to soils. We're looking at, somebody brought up the term carbon sink earlier today when we were doing this model over here, or this list over here, and versus carbon sources. So a sink is a place where the carbon is going to be stored. And so it's really interesting, start looking at these, it's kind of like an invitation to learning, looking at one of these maps. What do you see? What is this telling us? And so we have our friends in California where there's lots and lots of carbon sources. A little bit in Texas, it looks like West Texas, I guess Houston area.
Midwest is a huge carbon sink.
Yeah. And then the sinks, all of this is carbon sinks. Why do you think those are sinks? Why is there so much blue in the middle of the country?
Agriculture?
Could be agriculture, absolutely. Absolutely.
What is the difference between a carbon sink and a carbon source?
Sorry?
What is the difference between a carbon sink and
a carbon source? Thank you for asking that. So a carbon sink is where the carbon would actually be stored in the ground. It could be stored in microbial life. It could be stored in a plant material, but it's a place where it's actually in storage. Whereas carbon sources, usually we associate carbon sources with
where you get it?
High populations, where we have industry, where we have urban centers, and where the carbon seems to be kind of nestled in a certain spot. So it's so fascinating about our atmosphere. It's just so variable, and the gases are just so variable in our atmosphere.
So is it stored versus used?
I don't know about used. It actually,
or
actually used. Yeah.
Or produced.
Yeah. Your red would be used. Yeah. Absolutely.
Okay.
Yeah.
Stored versus used.
So then a place like New York.
It's neutral.
Neutral.
Yeah.
So it's using as much as it's storing.
Yep.
So the consumption is the same as the reservoir, essentially.
Yeah. So in the Northeast, that's a good question. You would think that, especially I'm from New Jersey, you would think that this whole state would be red. There's so many people living in there. Please don't move over. We have enough people. But we have so much plant life. We have so many trees and vegetation. A lot more than a turn of coming into the 20th century, where wood was what we burned and we cleared the landscapes. So a lot of those trees are back. 1, 2, go ahead.
The blue is that's a lot of our original prairie land, which is like freeze thaw every year. That layer of plant material ends up building up in the soil.
It could be, absolutely, as well as ag land and stored in ag plants, yeah.
Well, Illinois is a big, big mining state, so we have a lot of coal here. And especially down south, coal is big.
Yeah, yeah. It doesn't seem as if it's having an impact on the storage of it, though. You don't see a lot of red. There's a little bit of red. It looks like Chicago.
No, it's a sink.
Yeah.
It holds it.
Yeah, yeah, right. Absolutely, absolutely. Okay. This is another image. I'm going to go through this. This is just a carbon budget image. I know it's very light in your book, but ultimately you'll have access to those full slide decks, and so you'll get the bigger images of these. And so this image was from carbon. I'm forgetting the name of it. Global Carbon Project. And what they did is they actually measured numbers in looking at carbon being stored versus carbon going in the atmosphere. And I think the take-home piece here is that in the atmosphere, in the balance, it's plus 19, but they're showing an imbalance of a -1, meaning that we have more carbon than we are sequestering. And so I mentioned before about this variability across the planet. And what this model is showing us here is that here's our fossil emissions, and look at the United States and China and India and Europe. And then over here we have land use emissions, meaning that's agricultural practices and whatever other practices, limestone mining, all of those. Here is land sink, meaning that this is where carbon is being stored, and over here is ocean sink where carbon is being stored. And so our numbers here, I know you don't have this image. Again, the updated slide deck that'll be shared on the website will have this image in there. So you've got that. And so looking at the numbers here, we're looking at higher quantities where we've got blue, and over here we've got more emissions where it's darker. You have greater emissions where it's darker. And so you can start getting students to look at where they've got these fluxes. But the point of this is to show you that it's not all equal around the planet. So when we look at climate change, we need to be thinking about, and thinking about solutions, we've got to be thinking about this portfolio. Because one thing that works for where I live is not going to work for somebody that's living in the equatorial belt of the planet. And so we've got to be thinking a little bit more about the diversity of environments and the diversity of impacts and the diversity of emissions, all of these things when looking about solutions. Because one solution is not going to solve it all. There, in your booklet, there's talk about timing. When planning for this workshop, there was a GSA Today, Geological Society of America, one of their issues came out, and I'm looking at the cover, and I do this kind of with my issues, whether keep or read, and of course I saw soil on here and said, I'm keeping this one. And so the first article in here is the one that's actually in your book. And what it walks you through is this wonderful analogy of thinking about carbon and carbon storage in soils as a bank and a bank account. And something like this is very understandable, I think, for your students. And what you're going to see, I don't have time to go through this a lot because we're running out of time, but what you'll see is that one of the authors, Dr. Baer, she came up with this this cartoon. What do they call those cartoons?
Graphic novel.
Graphic novel, thank you. She came up with a graphic novel of basically what's in this article. And so what I provided for you, and you'll see it on the website, is a digital form of the graphic novel. So you can read the article for you. If your students are higher level, maybe juniors or seniors, give them the GSA article. If not, give them the graphic article, which tells them tells the same story about thinking about the carbon storage as a bank account. So let's walk through it real quickly. So we have the inputs are like our bank deposits. And so vegetation litter, root exudates, things that come out of the roots, living soil biota, deposition of eroded carbon, and remains of formerly living organisms. Those are everything that's going into the soil, but then we also have carbon that comes out that we can't avoid. Microbial decomposition, dissolved in particulate transport of carbon through leaching and or erosion, and Katie was the one that brought that up earlier today. And then we can also continue with this. We think about the cycling. And so here we're thinking now of, instead of bank deposits and withdrawals, we can think about our savings account and checking account. And so our savings account would be where the carbon's actually trapped down deep in the soil and locked onto the mineral matter that's in there. And then it's very slow to react unless we're being forceful, we're going out there and we're extracting. We can restrict decomposition, and that will end up keeping the carbon in the soils for a long period of time. However, checking account, where the money kind of bounces in and out on a regular basis, we can look at it as being readily degraded and easily transported. It's critical for the maintenance of life in soil decomposition, and is also a main mechanism that cycles nutrients in soil organisms. So bottom line, though, when we think about this bank account and soil sequestration, we're thinking about that we got to remember that there will always be withdrawals. As decomposition is needed for nutrient cycle, there will always be withdrawals from it. But what are investment opportunities? We need to be climate smart with soil management practices, and I'll walk through a couple of those in the next few minutes. There is an effort out there to get rid of some of the fossil fuels that are in our atmosphere by looking at what's called the 4 by 1,000 effort. So we want to increase soil carbon by 0.4% annually, and this would offset 1/3 of the global fossil fuel emissions. Isn't that amazing? Our soils can be that powerful, they play such a big role in our climate change issues. So this is from the article, and you have a deeper explanation of it in your pack when you read the article, but it's actually modeling where the storage can take place. So our forests are a key player here, so we can go through reforestation and plant a lot more trees. That'll help us out a great deal. Natural forest management, and being very prudent about how we log and use timber. Improve forest plantations, in other words, paying attention to what's taking place there and making sure that we're growing more and more. This one over here, agricultural and grasslands, is looking at biochar, cropland management, conservation agriculture, rice management, and grazing, and enhanced root phenotypes. And then over here is the wetlands, reforming and reworking the wetlands and enhancing them. So there's a link in the slide deck, which you'll have access to. There's a link in the slide deck that, for the sake of time, I'm not going to bring it to you. It's 2 minutes. It's a 2-minute video on soil sequestration. And it's from the University of Hawaii, but it doesn't matter if it's from the University of Hawaii. It means it's the same wherever we have agricultural practices. But it walks you through in an short animated way by changing up our soil agricultural practices, we can store a lot more carbon. Just to look a little bit deeper into soil carbon with your students, anybody here Globe teacher, Globe School? Okay, so the Globe School started, my goodness, maybe late 90s, early 2000, and it's where you and your students go out and collect field data and contribute it. And basically it's the data is actually used by scientists who use remote sensing. If you're a scientist using remote sensing data, you're looking at satellite data that's constantly looking down. But what you need to do, though, is you need to be thinking about, is what it's looking down and looking at accurate? And so by being on the ground, what's called ground truthing, we can actually contribute. The students can actually contribute to that. And so one of the ones that's a real easy one for them is what's called a cloud protocol. And students can look and identify clouds, and they'll actually send back a satellite picture of the day to the students for participating. But they actually have on the Globe sites broken down by spheres, and there's a whole suite, and in your book there's a couple pages, all the protocols on soils. And so it's a way, and here's the kicker, you don't have to be a Globe teacher to use the protocols, you can use them. So if you're looking for soil labs, just take a peek at those protocols that are on the Globe site, and they'll walk you through. Okay, and then I'll just quickly walk you through, I put together a soil and climate change 5E lesson, and something that you could possibly use with your students. Now, I made it kind of generic for kind of thinking about students that are in grades 6 through 12, and so you're going to have to think about your audience and what you might augment for your students in thinking about each one of these parts. So the phenomenon is thinking about the effects of soil on our climate system. So engage, the first step would be to be what I see and what I wonder, and what questions do you have about this very arid location? And so I was just looking for, I'm always looking for Creative Commons images so they can share them out without harm. But this is a drought. Actually, someplace in Italy there was a drought, and this is just the effects of it. So you can see that you have an impact not only in the plant material, but you also have an impact on the soil. So just to kind of get students thinking about the relationship between them. And so the Explorer, there's a website called My NASA Data where students can actually grab some data and they can actually create animations of data sets And so one animation is of monthly soil moisture, and the other one is of monthly precipitation. So they can look at them, if they have Chromebooks, they can actually look at them side by side, pair up the students, have one look at one and one look at the other. And you can have it set for the same amount of time. You can have it just look at one image that like I have here, or have them grab a whole bunch of images, and I said make an animation, and look at change over time, where there's greater soil moisture, and then where there's greater precipitation, and how the two follow each other. And there's an activity thinking about if there's too little water, plants actually are going to respond to that. And so under the leaf, there's stomata where that exchange of gases takes place. And students can actually do an activity that's related to this Withering Plants video clip that they're using nail polish to remove the stomata from the underside of a leaf. And they're looking at the number of stomata, plus also if they're open or closed, as related to dry conditions or wet conditions. Another issue that happens with soils and climate change is this issue of what's called salinization, where the salts actually come out of the soils because it's too wet, and then all of a sudden we have a drought. And so it has a little bit to do with the topography, and so I know it's difficult to see in this picture, but this little white piece over here is where you've got the buildup of salts. And this is a wonderful lab, a controlled experiment type lab I do with my students using Petri dishes and mung beans. And the students actually have to come up with their own salt solutions, their own level of salt solutions, and then watch over a period of a week collecting data, coming in at lunchtime to collect data. So it's a wonderful controlled experiment and getting students into researching, and so they can ask their own question related to that. Too much water, Dr. Dirt, Dr. Clay Robinson, has his own website. It's actually, if you Google Dr. Dirt, you'll come up to his website. And he's got the sponge model, and how using a sponge is a great way for students to understand the relationship between water and sponges, and using water and soils, rather. An activity that's actually, you can put it right to your backyard, is on the Stroud Center has a watershed, MyWiki Watershed, and they have the runoff simulation tool where students can actually manipulate the type of ground that they have and the extent of the precipitation event, and follow what happens to the water. And by changing the ground type, you can see some of it's going to go in ground, whereas other times you have runoff. And you know, they don't realize that having parks where the soil's compacted is almost as bad as having pavement, and that's something that would come out of that. So that would be kind of the explore part of this whole thing, looking at climate change and soils. And then explain, this is one looking at, students are looking more closely at soil respiration. And it's using probeware. Now, I'm going to suggest that if your school, your middle school, you don't have probeware, carbon dioxide probes are expensive, and we only had a couple in my building. But your high school might have a carbon dioxide probe, if you're lucky enough to have them, or maybe a mini grant can get a carbon dioxide probe. But I provided you with a link to go to this particular activity if you're interested. There's a reading, this is very user-friendly reading for students on soil sequestration, what it is, out of our friends at UC Davis. And continuing with the explain piece is that looking at, you know, this relationship between temperature and carbon dioxide, something's got to happen, and if we want to keep those temperatures down. And we go back to our notion of feedback mentioned earlier. And so we have this positive feedback and this possible runaway feedback loop. As temperatures rise, it leads to more drought, less carbon is sequestered, leads to more rising temperatures, and it just keeps going on and on and on. So elaborate. This is a quick little video, and many people don't realize that there's a relationship between water and sequestration of carbon. This video will actually walk you through that, about 10 minutes long. I would give students this, for Elaborate, I would give students the graphic novel piece from Dr. Bear, and have them read that. And then they can also look at solutions here in the Elaborate. And this is a Concord Consortium High Adventure Science. They have this one lesson or unit, I guess they call it. It's Earth, Can We Feed the Growing Population? And each one of their High Adventure Sciences has some kind of tool in there for students to work with, modeling tool. And this one is on managing agricultural systems, which is cool. And the students would actually use different agricultural systems, like tillage, no tillage, and look at the carbon sequestration related to that. And then evaluate. What does this all mean for me? What does it mean for me? And thinking about, well, what about my meals? My favorite things that are on my dinner plate and my breakfast plate, and what is that going to mean for me ultimately down the road? And so they can use the content and lessons set to identify how will changing climate affect the growth of crops for my food, how can agricultural practices be modified to ensure the crop productivity and sequester carbon in the future, and what can consumers do to contribute positively in regards to the food systems. And then to wrap this up, I would show them this on the soil carbon cowboys. This was a really great video, and even if you just watch it. It's these three farmers, one from Canada, one from North Dakota, and one from Mississippi. And they realized that they were going broke. And they were also realizing that climate change was in their back door. And so what they decided to do was change their agricultural processes, and they're now, as the carbon cowboys, trying to change other farmers to do the same thing. And what they do is they're changing where their livestock graze. And so they set up these small places where the livestock will graze, and then but for a very short period of time, and then go someplace else. In the meantime, they let that spot where they did graze go fallow. And then all of these grasses are moving back. You have all these nitrogen-fixing plants coming back, and all of these plants that are going to add to the nutrient cycling for that landscape. And it's an answer, it's an absolute answer to some of our agricultural issues, thinking about their processes. So I encourage you to watch that. Okay, so lots of NGSS, if you're an NGSS person, lots of NGSS connections. So, and with that, and there are some connections with the book that you have, No Soil, No Life. Take a peek at chapter 8, and then the Educator's Guide, and always send you to that. There's lots of great resources that Betsy put together for that.